we can convert the whole thing into what? The area, right? We can use what we call Green theorem. We can use what we call as a Green theorem. This means we can convert the whole form and we can solve this in a Green theorem. Del P, del X minus del P, del Y and dA. With this, okay, the whole thing. We need to bring it down, okay? Okay, can you see that? Okay, if it is the case, f is a 2D, then we can straight away we can use a Green theorem and it's equivalent to these 5 surfaces. Okay, I will explain to you what is this. I know you may have a many question. Why, sir? Why am I adding this 5 and it's equivalent to the path integral to this? Wow, wonderful concept, you know. Okay, I should demonstrate to you many logics behind this. But we have a lot of limitations here because I'm teaching through online, asynchronous method I'm using here to teach you by camera, you know, recording and that kind of things, but I cannot demonstrate many things here. Okay, but anyway, let it be like this. Okay, if it is a f is a 2D, then immediately we can use a Green theorem. Okay, remember. Okay, later I won't explain. Straight away I start using. Why you may say, wow, why sir, suddenly you're using Green theorem? Because it's a 2D. If it is a 2D, then I can use a Green theorem. Since why? Why am I using 2D Green theorem? Because it's a closed loop. Okay, if it is a 3D, no other option. Okay, no other option. You need to use one by one. You need to find out C1, C2, C3, C4. Okay, you need to find out. No other choice. You cannot use this 3D. Okay, 2D, PQ. Okay, I will show you how to use the logics, and very fast you can use the path integral to calculate the work. Okay, then you can equate this to the path integral. Okay, the idea, the first question, okay, the idea is, why are we using Stokes theorem? What is the usage of the Stokes theorem? Okay, what is the usage of Stokes? Okay, maybe let me explain to you this. Okay, can you see this object? Okay, can you see this object? Let's say this object is there. My son object is here. Okay, is it too big for you to see? Or too big? Yeah, maybe I'll just remove one or two, make it a little bit smaller. Okay, you can see this object, right? Okay, this object, okay, let's say this is an open surface and we surrounded with the boundary, surrounded with the solenoid. Okay, that means there is electric charges moving around here. Okay, let's say this is a building, imagine, or not a building, one kind of box. Okay, electric box, and the surface of this is, we call it as an open surface since it's open. Imagine this is open. Okay, and there is a solenoid moving around in this. Okay, now if the scenario here, I wanted to know where the ghost, the reaction of the ghost will act on me. Okay, let's say I use this pen. Okay, let's say I touch here. I touch this side. No reaction. Okay, no reaction. Okay, therefore, this solenoid, those charges moving around in this solenoid, actually not affecting me if I touch here. Okay, then I am touching here. It's not, anything not happened. Okay, nothing happened. Okay, and I'm start touching here also. Maybe there is underground or something like that. I'm moving like, okay, it's up bit. Okay, I'm touching, nothing happened. Okay, can you imagine? Segment 1, segment 2, segment 3, I'm touching, nothing happened. Touching here, nothing happened. Wow, but when I go and touch this side, immediately I die. That means the ghost is sitting on this surface. Okay, on this surface. This is the benefit of Stokes theorem. Okay, the Stokes theorem will help you to identify where the charge actually sitting on the surface. Okay, that's why you can see it's actually when this is the moving around, you can identify in which surface, okay, in which surface, and once you add up together, you should get the same. Therefore, it will let you know in which surface, okay, the ghost is sitting. That is the beauty of this Stokes theorem. Okay, Stokes theorem will let you know, but it's a tedious task. Almost student will ask, sir, can I use this to calculate? It's an easy method. Why are they introducing this? Okay, making our life more difficult to find out the surfaces of each, okay, segment. But the reason is very simple. Okay, individually you can able to track the forces or the action or the work that can be giving impact to your to anybody, the external sources, to the external sources. This is external, right? The pen, when it's sitting, is pen, of course, never react lah. But I'm saying is there is a ghost, it may pull or it may push. It's not a pull, actually most of the time it's a push out, or maybe it may react. I may call it the ghost may react. Okay, that's the idea. Okay, now let me show you how am I going to calculate this logics. Okay, let me define the segment here, all these segments. Okay, very quickly I'll define the segments here as A, B, E, F as S1, E, F, G, H as S2, B, C, F, G equals to S3, C, D, G, H as S4, and A, D, E, H as S5. Okay, remember, you cannot include the open surface. Since it's open. The consider virtual. What I mean by that, it could be actually open or not. It doesn't matter. The message that I wanted to give you is the solenoid surrounded the boundary. Okay, we call it that as an open surface. As long as you see some solenoid moving around the surface, we call it that as a open surface. Remember, and we should not include the surface integral of that, okay, open surface in our calculation. Can you see this? In our calculation, we didn't include the ABCD open surface. Okay, therefore you see it's a lot of works. We are combining the line integral plus we just combine the 5 segment of the surface integral, then we are trying to prove this equation. Okay, that means the question, once you get verify, you have a tough time, because you need to verify this side and this side as well. That means it's a lot of work for you. Okay, you need to do step by step individual work very fast. Okay, let me show you how am I solving this. Okay, in this particular case, let me go through with a very fast way to handle this problem. Okay, since we know this, okay, question here, the question is a 2D or 3D? Very clear. Okay, question is about 2D. Okay, very obvious questions indicating this is a 2D. Okay, it means I can very fast, I can combine the C1, C2, C3, C4 using very quickly. I can use this, and what I mean by use this means is a green theorem. I can calculate. Instead, I work one by one. C1, C2, C3, C4, making my life more difficult, right? Therefore, it's easier. I can use in a one go. I can use a green theorem. I can prove this. Okay, let me show you how am I doing this. Okay, are you ready? Then let me introduce to you the first segment, which is we can very fast we can calculate the things. That means it's if let's say the question is verify, put it as a verify, you need to verify both. You need to show both. I already explained to you. If the question is just fine, you can use either one of this. If they ask you verify, you need to use both. You need to show both. If they just use the word called find or calculate, then you can use either one of this formula. Okay, you get me or not? Okay, that's very important. Now let's say we imagine this is a verify, for example lah. Okay, therefore the first effort that I will say, since f x minus y I x2 yj is 2D, we can use what? We can use loop FDR Green theorem. Okay, can I say del f? Okay, can I call it this as what? You want to call it PQ? Can. Now you can use PQ or F1. Maybe I call it F1 lah. No problem. At least you know what I mean by that. F1, F2. Okay, let me show you. Can you see that? F1, F2. I didn't use PQ. Or you want me to use PQ? Whatever. I want you to learn different variables lah. I don't want you all to stick to this PQ always. Okay, as long as you know how to do your problem. Okay, del F1 to the del Y. Okay, remember F1 is del F to del X, and which is dA. Okay, which is dA. Else, remember, since if the case is a 2D, we can use this. Okay, definitely. Okay, imagine else, I put this word, else if the case is f, let's say f1. Okay, can you see that? Can you follow me? Let's say f2j, f3k, 3d, and the ghost is 3d. Then we can calculate. We must calculate. Then no other option. We need to go for the tough way, where S is a interior circles, where the S is the interior circle, interior of circle, or maybe it's not a circle, curved boundary curved. No space for me to curved closed boundary closed curve. Boundary closed curve, maybe that's better sound, you see. Closed curve. Okay, see. Okay, let me come back to the question. I haven't solved the question, but I am giving the idea again and again. I am emphasizing this very important one. Okay, very sorry for the last here, this message. I am trying to say, if the case is a 2D, you can use Green theorem. If else, let's say in our case it's a 2D lah, this is understood. But if the case is else, if the case is the ghost is involved 3D, no other option, you need to go and do it. Let me show you how am I doing this. Okay, now in this particular case, okay, we use option 1. Okay, we use option 1. Can you see that? Okay, we use option 1 using Green theorem. Okay, using Green theorem. Okay, using Green theorem, whereby we just Okay, I'm going very slow, very slow, I know, but I worried because this topic is not easy. It look easy, but actually I don't know lah. It's too complex, Therefore, I need to be very careful. This is negative axis, negative outside and the okay. Now take it very fast. Okay, take it very fast. Okay, what is F1? What is F1? F2? Just take it F. It's x minus y. F2 is negative x2 y, right? Okay. Okay. Can you see that? Okay. Now this is F1. This is F2. Okay. Now can I perform del F1 del y? Yes. Negative 1. Can It's easy. Can I perform del F2 del x? It's a negative 2xy. Can you see? This is very important. Not exact. It's not exact. If it is not exact, green. Can you use a green? Yes, you can use a green. Okay, combine together. Therefore, you can calculate FDR negative very fast. Okay, very fast, whereby you can say negative 1 plus 2xy, negative, negative is a 2xy, okay, dx dy. How I know? How am I know dx dy? See, look at this. How do I know? This is very important. I must refer this one. See, this is dx dy. Sorry, dx dy. Okay. Okay. Now, can I fix the number here? Okay. What is the best way here? What is the higher value that we can go here? It's a 3 and 2. Can you see that? That means it's a 2 to the 0, 3 to the 0. When you calculate, you get negative 12. Wow. Very fast we solved the problem. Okay. Very fast we solved the problem. Okay. Now we use option 2. Okay. Option 2 using Stokes. Okay. Stokes Theorem. Okay. We use Stokes Theorem. Stokes Theorem. Okay. Therefore, you see same approach. You see we are finding for the dr del f times with nds. Wow, we need to do how many segments? 5, it's not a joke. First, we need to start working on this. I teach you this part. Okay, please learn the skill. I'm going to use the same, but I'm going to say, okay, this is sun, right? Okay, let's say you say no, sir, can I use Stokes theorem to test this? Yes, you are allowed. You see how am I going to show you? Okay, we can use Stokes theorem, whereby, okay, in this case, how many steps you need to do? 5 segments. You need to identify the 5 segments. Okay, you need to use S1. You need to do S2. What is S1, S2? Yeah, S1, A, B, E, right? S3, S4, S5. Okay, I'm not going to show all, but I show you the logics of this. Okay, now you need to expand this. You need to bring this formula for 5 segment, then only you will get this results. Wow, one single work. Remember, you must remember, we already solved this problem quite comfortably with this. Okay, we use option 1 green theorem because it's a closed loop. Okay, if you don't use it, otherwise you need to go for C1 plus C2 C3 plus C4. We already cut short all this work in one single work like this. Okay, now that's why green theorem solved. Now we're going to use the Stokes theorem. We're going to call father. Okay. Now this one we're going to find out 5 segments like this. Okay, let me show you one by one. Okay, first of all, del F. How to write this? Okay, I. Okay, I. J. K. Del X. Del Y. Del Y and del Z. Okay, this is x minus y. This is negative x2 to the y. We know f is only 2, you know. What about this? Is there k exists? That means you cannot ignore this, you know. You need to include that as a 0. After that, when you calculate back, something you will see, you may find out something, there is some similarity here. Can you see that when you calculate here, this one, you will get this 2xyk. Can you see that? Same as this. This one, yes. Can you see that? Green theorem also same. If I bring inside, if I bring this negative inside, you will get same as the results. Can you see that? Okay or not? Okay, some of you cannot see, right? Okay, if I bring the negative inside, it becomes positive 1, negative 2xy. Can you see this? Positive 1, negative 2xyk. See, you will get the same. Okay, you will get the same. But you can solve over there very fast, but here you need to have a tough time. You need to find out S1, S2, S3, S4, S5. Okay, long way to go. Okay, let me finish at least one example. My battery is an issue. Okay, A, B, E, F, which is S1. Okay, okay. In this case, what is A, B, E, F? A, B, E, F. Direction outside. Okay, can you see that? It's a Y. N is a I. That means it's a N, it's a I. X equals to 3. Therefore, del times F times with the N, you get 0. How do I know? Simple, right? See, and I. Okay, you see, this times with the I definitely is a 0 because you never get anything, right? You don't need to worry. Okay, since we are time dot product with us. Okay, when you use a dot product to the n, ik definitely is a 0. Okay, you don't need to calculate. Okay, we have skipped the first step. Okay, similarly we can calculate for E, F, G, H as 2. Okay, still see the same. Please check. N is a K and Z equals to 4. Can you see this? E, F, G, H. Okay, here, this one, up. Okay, the what do you call the normal is a Z, right? That means it's a K. Clear? Z. Okay, can I calculate this? Del times with the F. And yes, we get a 1 minus 2xy. Then what is the dx here? Okay, we need to calculate this one. Okay, when you calculate ds here, the ds is a dx dy. Okay, of course. See, we are calculating dx dy. Okay, now when you start calculate this, you will get the solution. Try and see exactly as 2. Okay, 2 same as this, right? Same as this. I hope that you can calculate by yourself. Please try. Okay, 1 minus 2xy, where you get the solution is negative 12. Wow, S2 is 12. Okay, if S2 is a 12, can I say the rest all 0? No, please don't do that. I already told you before, because it can be negative 2, 2. That means when you calculate, of course, when you add up, it's a by nature it should be 12. No doubt about that. Okay, now we know S2 is a negative 12, but this one can be 2, this one can be negative 2, okay, or anything else, but same. Or this can be negative, this can be 10, this can be negative 5, negative 5. Okay, just to get this results. Therefore, you cannot yourself, you conclude, okay, once is this is negative 12 ready, then this is 0, of course this 0, 0, 0. No, don't do that, huh? Please don't do conclude. You assume yourself. Cannot. You cannot assume yourself. Okay, the last portion, okay, S2, okay, we go for BCFG, which is S3. The n is a positive j. But of course, when if positive j, we know already, with the times with the f and we get 0. Wow. Okay, maybe in this particular case then, wow, yeah, in this particular case you are lucky, your guess is correct. Maybe you say, wow sir, can lah sir, can guess lah. Okay, but not all the time, again. Okay, yes, in this case it's a n is a negative j, therefore we get a times with the f and times with the n, of course is a 0. Okay, no other options. Therefore, in the basic conclusion, we can say del to the f and ds, whereby here S1 plus S2, okay, S3, and okay, you are lucky, huh? Coincidentally, it's indicated here as a negative 12, huh? It's not all the time it will happen. Okay, that the first example done. Okay, we take a break, then I will continue. What will happen if the case is a 3D. Okay, we will go for the 3D, then I'm going to choose few examples for you, and I'm going to explain to you how the cases are going to make the problem more complex, step by step. Okay, I'm going to put it the circle, I'm going to show you a rectangle, I'm going to show you what do you call, tedra, and different polygons, maybe 1 or 2 examples lah. And one of the things is a spherical. Okay, how do we handle the spherical cases? Okay, with that, okay, we take a break, can we, for the moment, then we continue the next example. Thank you.